Welcome back to Fundo Academy. We are on irrational numbers. Remember, in the previous lesson we talked about surds, and we're saying that surds are irrational numbers expressed with a square root. So in this video we're going to be learning how to simplify surds. So we're going to be talking about simplifying surds. Alright, so in order for us to be able to simplify surds, there are two important points that we need to know. This is the first one. Now, according to this first point or principle, if you have a surd, a square root of a product, like in this case we've got the square root of AB, which is A times B, it will be equal to the square root of the individual numbers A and B, the product of the square roots of the individual numbers A and B. So the square root of AB is equal to the square root of A multiplied by the square root of B. So that's the first point. The second one is to do with a division or a fraction. So we are saying that if you have the square root of a fraction A over B, this will be equal to the division of the separate square roots of A and B. So we'll be getting the square root of A divided by the square root of B. So that's the second important principle here. So these two points will help us when we are simplifying surds. So we're going to be starting with the problems involving the first principle right there. So let's look at an example. Simplify. So let's move on to the solution. Okay, on part A we want to look for the square root of 20. Alright, so the way to do it is to look for factors of 20, or to express 20 as a product of factors. But you see, 20 has got many factors. The way to do it right here would be to consider mainly perfect square factors of 20. Like we know that 20 is equal to 4 times 5. So the square root of 20 is the same as the square root of the product 4 multiplied by 5. Why have I chosen these factors specifically? Is because one of the factors here is a perfect square, that is 4. So you see, that's why I have chosen to write or to express 20 as a product of factors involving the perfect square factor, which is 4. And that's important for us because now if we are to apply the first point or principle right here, then this will mean that this will give us the separate square roots of 4 and 5. So that will be root 4 multiplied by root 5, and the square root of 4 is 2. So our solution will come out as 2 root 5. So that will be our solution for part A. So that's simply how we handle such a problem. Okay, I hope you got that one correct. Let's move on to part B and see how we can handle the question on part B. Part B, we want to look for the square root of 150. Again, we do the same. We are trying to express, in this case, that's 150 as a product of factors, and we are mainly considered perfect square factors. But you see, 150 is a bigger number than 20, and the bigger the number, the more difficult it may become for you to be able to find the factors or to express it as a product of factors. So what you may do is we can look for the prime factors of 150 this way. This should be familiar. So we place our 150 here and we begin to divide 150 by its prime factors, starting from the smallest one divisible. Like here, 2 can be divided into 150 to get 75. That's a prime factor 2. Remember, we talked about prime numbers in the previous lesson, or prime factors, right? And now we can divide by 3, and 3 into 75 will give us 25. The next prime factor here, smallest one divisible into 25, is 5. 5 into 25 gives us 5. And we also divide 5 into 5 and we get 1. So what you're seeing here are the prime factors of 150. So we can express 150 as 2 multiplied by 3 multiplied by 5 squared. Remember, 5 squared is equal to 25, right? And the square root of 5 squared is 5. The square root of 25 is 5. So since 2 multiplied by 3 gives us 6 and is not a perfect square factor, so we can express these as separate square roots. That is the square root of 6 multiplied by the square root of 5 squared, which is 25. And this will give us the square root of 5 squared here is 5. So multiplying 5 by root 6, then what we'll be getting is 5 root 6, and that is our solution to part B. That's the answer right there. So that's simply how we can look for, or I mean, we can simplify such a surd like 150. Now part C has got a bigger number, which is 588. What I want you to do, since you now have an idea of how we do it, I would want you to pause this video and maybe try to work on part C. So I'm just gonna give you just 2 minutes to do that. Alright, so let's look at 588. Again, it's another bigger number, so we can perform this operation to look for the prime factors. First, dividing by 2, and 2 into 588 will give us 294, and 2 into 94 into 294 we get 147, and here we can divide by 3. 3 into 147 will give us 49. Again, we divide 7 into 49 and we get 7, and 7 into 7 we get 1. So we now have our prime factors. All these are our prime factors. Alright, so we can now express 588 as a product of 2 squared multiplied by 3 multiplied by 7 squared. Alright, and these are separate square roots. That is square root of 2 squared multiplied by square root of 3 multiplied by square root of 7 squared, using our principle. And the square root of 2 squared is 2, right? And it's multiplied by the square root of 3, which cannot be simplified any further, and the square root of 7 squared, which is 49, is 7. So simplifying this, multiplying 2 and 7, we get 14. So our solution comes out as 14 root 3. And I just hope you got that answer correct. So this is the method. This is how we can simplify surds into simpler form. And I want you to go back to each and every one to see how we're doing it, maybe trying to work them out yourself, and so that you may have it on your fingertips, because it's very important for us to know how to simplify surds.